Hello everyone. Now let's move to the Excel practice. So we will start with the basic put call, payoff, profits, then go over some strategy, then move on to Black-Scholes and binomial. Okay. So here I copied the formula to calculate call holder and writer's profit. Okay. Suppose we have a call purchased at $2.50, strike 50. And what we want to do is to use the formula to get the net profit from both call holders and call writers' point of view. Okay, let's go. Right. Okay. So for call holders, the net profit is whatever we want to do is compared to 0 because you can walk away. Then compare the difference between the stop price and the strike. Log strike. Right. So do not forget to subtract the cost of the call option. Okay. Right. As you see, right. So when the price goes up, the call net profit starts show positive. For call writers, let's also get familiar with formula. So call writers are getting the premium first, then see if the other party is going to exercise. So the difference between stop price and the strike again. Right. So as here, it's a total opposite. Total opposite. Right. So how do we create a chart? We can go to insert. I can select stock level and the payoff and go to insert chart. You can use scatter with a line connected. Okay. Right. Here we use max function. You can also use if functions to see if the stock price is greater than strike, then we do the difference, otherwise 0. That will work the same way. Okay. Now move to the put option, we will do the same. Okay. So put holders, we are looking down the stock price movement. We are betting price go down. So the profit function is we use max function again, the minimum 0, right? So then compare the strike with the stock price. Again, we have to subtract cost of the put option, right? So when the price go down, the put is in the money. But if it's above, then out the money we lose 250. So provider will collect the premium first, then see if the other party is going to exercise. Right? So you can see it's total opposite. Total opposite. And we can also display them in the chart to see the relation between stop price and the payoff. Right? So that's basic call. We can put them together to the option strategy like protect put we mentioned before. Suppose you have a stock and the put option and how we understand the payoff, right? So we can do that. We have long position put. We will use the put options formula, 0, difference between the strike and stock minus the put cost or premium. All right, then for the stock, we just simply compare the stock at the moment and the purchase price. Okay, so the total net profit is 2 things because we only have 2 things inside our protect put, right? Inside put. So this 3, another way to analyze 3 is you can think about this is the strike 25 minus the total cost of your your protect put, which is $2 plus 20. Okay, so that is the same thing. Anyway, what I'm going to do is I'm going to again show that the net profit. As you see, if you look at the green one, right? So this is our protect put profit chart. Right? Very similar to the call, as you see, right? The call, the blue one. I would encourage you to do the other variations. You can have like one put to one stock or different ratios, like one stock, two put, so on and so forth. Okay. So I here also has another example to do, okay, call, buy one call, sell one call. Let's see. Again, we will use the formula. We can use breakdown, right? Buy one call option, again, compare 0 with stop price minus strike, and then subtract the call premium call price. For the right one call, we will use $2 premium first, then look at the max function 0 and stop price minus strike. Okay, so you can also add up total. Right, so this is our payoff. As you see, as our buy at higher strike, sell the lowest strike, as a result, you will see it's like a bear spread. Let's see the chart. Right, if you look at the green one, it looks like a step down, right? The bear spread. I have also another one for you to practice a color and see if you can get and show that the net profit of total display then on the chart. So that's the basic put call profit and some basic option strategy. What I'm going to move on is review Black-Scholes model. Okay, here I have example for Qualcomm. I have downloaded historical stop price for the Qualcomm daily frequency. We also have Qualcomm's stop price at closing and the option quote that will expire February 2018. We have all this information. So what we're going to do is we're going to fill out part B and compute stock price at daily frequency, calculate the daily standard deviation convert to annual standard deviation, then finish the rest of the part B, then compute D1, D2, and D1, D2 call price, part D sensitivity, and implied volatility. Okay, ready? Okay. So task number 1, daily standard deviations. So what we're going to do is, so the date is ascending order. This is stop price adjust close. So we can, usually we will log formula, okay, as we tend to assume continuous movement. So we copy down all the way. So I have 2 years daily stock. Next, we will look at a standard deviation. Okay, so you can use sample pool. I will use standard deviation pool. And so we look at a standard deviation of the whole series. That's quite a few. Do you still remember what is the factor we have to adjust to convert to annual? Anyone still remember that? Times square root of what? How many active transaction day do we have over 1 year? Right. Okay, so that's a lot, right? So if you have this, you will notice, wow, this is so small. So this is a stock price, daily frequency, get return, get standard deviation convert to annual basis. So we will now finish the rest of the Part B table, the 5 inputs. So most of the information are given from the quotes, right? So we will just enter the average of the average is closing price. 68.14 is the Qualcomm closing at that day. Strike, look at this. This is strike 65, right? 65 indeed. Strike is set at 65. Okay, so the date. Okay, so at the time when I construct this snapshot of the stock price call option, it is November 27, 2017. So the option expires date is February 16, 2018. So we have to compute the actual date here, 2/16, 2018, right? So the time to maturity, we use calendar date, but we have to use the number of years. So look at the number of days, then over the actual number of calendar days. Okay. So if it's 6 months, it's half year, right? So everything have to annualized. So this is something given. So risk-free rate, annualized rate, we assume 2% here. So part B. Part C now, it's all formula, D1, D2. I will ask you to take a pause and practice on your own, see if you get it. A lot of students have issues with the order of operations, which one first, which one second, and I would say put necessary parentheses in order to make the order correct. So D1 on top, we have log, stock over strike, plus then risk-free, standard deviation square, over 2, the whole thing times the maturity. Now I need to put parentheses outside the log and this second term. Then divide standard deviation times square root of t. Okay, so after we plug into formula, we got D1 0.45258, D2 0.318774. Now let's compute ND1 and ND2. So Excel has a norms dist function. It is standardized normal distribution probability return function. So all we need to enter D1 or D2. Right. So it is accurate and there is no roundings. Okay. So all these will help us to figure out the Black-Scholes model call price. Stock times ND1 minus the strike, E, sometimes we use E, sometimes we use X, strike, time, exponential function. Here we have a negative, risk-free. We have a negative time risk-free times T. Okay, so all in the power, then time and D2. So we got 5.52 according Black-Scholes model. Okay, so that's part B or part C. Fill out the input, then we will go to the calculation and find Black-Scholes. Okay, now we assume the risk-free 2%. Maybe there's something like the risk-free is a major factor. We want to see if it's going to be a sensitive factor on our core price. So what we're going to do is, okay, so let's select the area, go to our favorite what if analysis, go to data table, right? So this is in the column, the risk-free in the column, and the risk-free is in our input part B, risk-free is 2% here, 0.7, right? Okay, so seems like some slight effect, but not as major, right? Change from 5.36 to 5.68, right? So you can perform other sensitivity to see other variables. Okay. Part E asks you to find out implied volatility. So look at our calculation. We got our call price 5.52. The current quote, if average bid ask is 5.35, right? So suppose we want fit to 5.35. So what kind of standard deviation will make this to 5.53 here? So this is the formula. So we want to find out what is the required standard deviation so we can fit our core price to 5.35. So to do this, we need to have initial number. So this is formula equal to this. Go-seek cannot replace a formula. So what we want to do is this input, we want maybe just copy paste to a value. Okay. So let's try again. Okay. So I'll set our output to 5.35. Remember, our changing set is already a value, not formula anymore, because formula equal to this, they cannot, right? So we caught, the answer we found is use go-seek. We found that the annual standard deviation have to be at this level. This will fit our result to 5.535. So another word, according to the market price of this core option, we inferred the implied volatility or standard deviation is 26.96. So this can be used for the overall market index S&P 500 as well to help us to get a sense of the implied market volatility. So that's Qualcomm. We will do additional practice later. What I'm going to do next is to do a binomial model. So this is a one period setup. So first, what we do is to fill out the predict stop price. What we want to do first is to predict stop price at period 1, then payoff of the call or put option at period 1, then calculate the stake price. Then we will figure out what is our call price and put price. Okay, so first of all, so this is as assumption. Initial stop price is 50. Okay, then if it's go up, it will move up by 1.1. Okay, and if go down, it will go down to 97%, right? So that's okay. Okay, bound I already finished for you. So now if the option struck at 49, so we will use max function look at 0, compare the payoff at period 1 and minus the strike, right? So whichever is greater. Then same thing, we can also compare 48.5 with 49. For the put option, we will use max function of 0, but this time we will compare the strike versus the stop price, right? Okay, so we can do this, and when the price go down, we also have a positive put payoff. Okay, so that's step 1 or 2. Now next we will use this formula, compute the up-down stake price. So we have I as the interest rate, D is 97%, U is 1.1. So let's do that. 1 plus I minus D over 1 plus I times the difference between U and D. Okay, so you have to do QD as well. QD is not 100% minus, it's not probability U minus 1 plus I. Then we will do 1 plus I times the difference between U and D. The denominator is the same. Okay, so that is QUQD. Okay, QQD. So use QQD when we know the possible option payoff in upstate or downstate when the stock price goes up or down. Now we can figure out what is appropriate price we should give for call or put option time zero. So basically, it is the payoff time the state price. Although it's zero, I still will use the QUQD formula. Just have it. Same thing. We can do that for the put option as well. Right. Okay. Sounds easy. Right. Sounds easy. Right. So once we know, once they set up the relationship, we can just use this formula relationship to pricing the call option or put option. This can easily extend to a two-period model, right? So same procedures. Same procedures. So what I'm going to do, let's see. Right, so what I'm going to do is still use the same formula, but this time we have up or down, right? So this time down, the ratio, the probability is different, but it is the same idea. I'm going to okay, so you can see go up, go down, right? Bond price, I will skip that. Now for the option strike 40, initial 30, here same thing, right? What we're going to do is use max function, compare with 0 and whichever is greater price minus the strike. Lock the strike. We can do the same thing for this. Remember our option strike is very high, 40, right? So what we're going to next do is we will use state price. Okay, let me see. Okay, this time it's symmetric, happen to be the same, but not always the case. Not always the case. It's just a pure coincidence. Okay. So once we have that, what we do is we will use the state price to help us to price. So QU times this plus QD, the downstate, time that, right? Okay, so of course, we can use very similar way to get our call price at time 0. Okay. Okay, so this is our call price. So if we play with different strike like 35, let's see, for example, say 30. Suppose 30, right? So then we have different payoff. The option price also different, right? So this is two-period model. The procedure are identical to one period. 1 period. You can also extend to the 5 period for the same procedure. Okay. So this Excel, we kind of reviewed the basic protocol, some strategy, and how to find Black-Scholes and binomial.